Hello everyone, so in this STR8CHEM session we're going to look at this question where we're going to find out what is the theoretical yield for AlCl3. Okay, so this is a stoichiometry question. Therefore, what you need to do first, you need to ensure that your equation over here, you have to make sure that this is balanced. It's very important. So as you can see, the equation given to you is already balanced. So step one, what you need to do if you have questions like this, when they want you to find theoretical yields or they want you to find out percentage yields, step one will always going to be looking for balance equation. Okay, so this one is okay, it's already balanced to you. And step two, we need to find out of the mole of your reactants. In this question, you have two reactants given to you. You have aluminium and you have chlorine molecules, okay? And the information given to you in the question is in the form of grams, okay? So we need to convert mass into mole. So to convert mass into mole, you need to remember to convert mass into mole, what you need to do is you need to have your mass over molar mass. Okay, so to do this, what you need to be able to find out is the molar mass of your aluminium and molar mass of your chlorine molecules right over here. Okay, so let's try and do for aluminium first, shall we? Okay, I'm going to use this. So mole of aluminium okay, so we're going to take the mass over here, which is 20.0 grams over, and then when you look at the periodic table, the molar mass of aluminium will be 26.98. Okay, 26.98 gram per mole. And you should be able to get 0.7413 mole. Okay, so that is for aluminium. What about for chlorine? Okay, so for chlorine, mole of chlorine, so the mass is 30 grams. So you have 30 grams given to you. So these are the masses that you have when you do this experiment. So we call this as the given mole, okay? Given mole and given mass. So the number of mole of chlorine molecules is going to be about 35.45 times 2. Why do I times 2 over here? Because you have 2 chlorine atoms in one chlorine molecule. And the number of moles should be 0.4231 mole. Okay, so both of this mole here, this is what we call as given mole. Okay, why is it given? Because these are the mass that is provided to you, that is given to you. that you have in hand when you try to do this experiment. Okay? So you've done step 2. Usually in examinations, they're going to give you, perhaps they're going to give you 1 mark over here for correct number of mole, and another 1 mark over here for correct number of moles. So it's very important for you to find out the number of moles. So a very good tip for this kind of questions, if you really don't know how to start, okay, but you do know that you need to have a balanced equation, always try to work out the try to work out your mole. Try to find the number of mole. Okay, then you will get at least 2 marks over there. Right, now let's move on to the next one. Okay, so as you can see, these are the given mole that we have worked out. We worked it out just now. Okay, so these are the given mole. So what we're going to use with this given moles over here, we're going to use this one to find out who is the limiting reactant. Okay, it's very important for us to find the limiting reactant because the number of mole of the limiting reactant is the one going to determine the number of mole of your product. Okay, so I'm going to write down a little note right there. Okay, why we need to find limiting reactant? Because it determines mole of product. And you need to remember, we want to find out this product theoretical yields or theoretical form. So this is your product over here, okay? And the number of mole of this product is determined by the limiting reactant. And we have 2 reactants. We have reactant number 1, reactant number 2. And which one of them is the limiting reactant? We're going to do something what we call as proportionality. So I'm going to try to look at comparison. I'm going to compare both of them. So from the balanced equation, okay? So from the balanced equation, we know that 2 mole of aluminium will react with 3 mole of chlorine molecules. Yes? So the one in blue, okay, the one that I have written in blue, that is what we have got from the balanced equation. That's why in step 1, it's very important for you to find the balanced equation before you want to do the proportionality. Without the balanced equation, you cannot do the limiting reactant. And then the second line, I'm going to write something at down here from the balanced equation. Okay, so let's say I'm assuming that the chlorine might be the limiting reactant. At this point, I really don't know. I'm just making a good guess. So if I want to check or if I want to test whether the chlorine is going to be a limiting reactant, I'm going to write this given mole. Okay, you have this. This is what's given to you. Given mole of the aluminium just now. Okay, so I'm just going to try to write that in different color, I think. So you can see that clearly. Okay, so the one in green will be your given mole. Okay, so right over here, I'm going to write X. Okay, because I don't know yet. Okay, I don't know whether it is, how much do I need for chlorine if I have 0.743 mole of aluminium, okay? So, because we want to test whether your chlorine is going to be the limiting reactant. If you want to test whether your aluminium is going to be the limiting reactant, then you're going to leave the one over here going to be X. And you're going to put the number of 0.423 down here. If you want to test like that, you can do that too. But now I'm just going to try to guessing that maybe chlorine is going to be a limiting reactant. Okay, so I'm going to do a cross multiplication. So we're going to times this, divide by that. Okay, so you times and you divide. So 3 times 0.743 mole divide by 2 mole, then you get about 1.11195 mole of chlorine. Okay, because we want to figure out what is that one. So that is needed. So this is they needed chlorine. Okay, so you have this needed. Okay, so this is your needed chlorine. Okay, so you have your needed chlorine over here, and then you compare with your given chlorine. Okay, so is that even more? You have, if you have 0.743 of aluminium, you need 1.11195 mole of chlorine, but given to you is 0.4231. Therefore, your chlorine is the limiting reactant. Okay, so I'm gonna write that again very neatly over here. Okay, so we have figured out just now your given, okay, given mole of chlorine is 0.4231 mole, but your needed mole of chlorine is about 1.11195 mole. So what you have, what is given to you, is lesser than what you need. Therefore, what you can conclude over here is, therefore, chlorine is the limiting reactant. Why? Because the given mole of chlorine is lesser than the needed mole of chlorine. Okay, so this is a very, very important statement that you need to write in your answer. By writing this statement over here, you will get 1 mark. Okay, so if I'm going to go back to this huge mess over here, by doing this proportionality over here, you get 1 mark. And then by figuring out the mole of needed, you get another 1 mark right there. Okay, so that's so important for you to know. And then you're going to write this statement. That's good. Okay, so now we know who is the limiting reactant. And we have figured out the limiting reactant. And once we have figured out the limiting reactant, we can start to work out the product. We can find the mole of this, because we already know that I'm just going to put, okay, chlorine molecule. So chlorine molecule over here is your limiting reactant. Okay, so what you need to do now, in order for you to find out the theoretical yield of your product, we're going to use the given mole of limiting reactant. Okay? So given mole of limiting reactant in this case, so who is your limiting reactant? Cl2. So the given mole is 0.4231 mole. So common mistakes that students always do at this point is they're going to use this one instead. So when they have figured out what is the needed mole, they use the needed mole to find out the theoretical yield, which is incorrect. Okay, so you need to remember. So when you reach to this point, when you want to find out the mole of your product over here, we need to use your given mole of limiting reactant. Why? Because the given mole is what you have, not the needed one. You don't have the needed one. You need that, but you don't have that. Okay, but you have the given mole. And that is the limiting reactant. And we're going to do the same exact thing. We're going to do a proportionality. But this time, instead of comparing between reactants, we're going to compare your limiting and your products. Okay? So from the balanced equation, we know that 3 mole of Cl will produce 2 mole of AlCl3. Okay, so what is the given mole of chlorine? The given mole of chlorine is 0.4231 mole of chlorine. And over here, we're going to put X mole of AlCl3. Okay, so when we do the cross U times, okay, U times, and then when you go up, you're going to divide. Okay, so you have, so the X mole of AlCl3 is 2 times 0.4231 over, divide over here, divide by 3. You have 0.2821 mole. Okay, by getting this mole over here, you get another 1 mark. And by doing this proportionality, you get another 1 mark. Okay? But do we stop right over here? No, because we want to find what is the, so we want to find what is the theoretical form of your AlCl3. So if you stop right over here, you're going to lose about 2 marks because the last 2 steps, you need to convert this mole into mass. Okay, so how do we do that? Okay, so how do we do that? How do we convert that into mass? Okay, so just now we have worked out. So now we want to convert Okay, so we have mass of equals to 0.2821 mole. This is what you have got just now, okay? 0.2821 mole times with aluminium is about 26.98 plus 35.45 times 3, and what you get here is 37.6124 grams. Then you get this, you get 1 mark, and this calculation over here gets another 1 mark. Okay?